Hello everyone. Welcome to today's YouTube lecture. I am Dr.E.Purushotham, Professor of Physics, Department of Basic Sciences, School of Sciences and Humanities at SR University. In our today's class, we are going to discuss a very interesting and important topic in laser, that is absorption, spontaneous emission and stimulated emission of radiation. So these three processes are very important for understanding the interaction between atoms and light, or the electron is incident with the atom. More importantly, they help us understanding the basic principle behind laser technology. So let us understand these concepts only one by one, starting from the basics. So here you try to understand this curiosity question. Whenever we talk about lasers, one question naturally comes to our mind: how exactly is laser light produced? So to answer that question, we need to understand how atoms interact with light. An atom can absorb energy and move a higher energy state. It can also come back to a lower energy state by releasing energy. That release can happen in two different ways, that is, spontaneously and through stimulated or stimulation. So, by understanding these three processes, we can build a clear picture of how a laser works. So, before we go into the physics or in laser, let me ask you an interesting question. Have you ever wondered how your smartphone recognizes your face so quickly? You can see here. So that is Face ID. How does Google Maps, you try to see here, how do Google Maps estimate traffic and suggest a route. And coming to this self-driving car, and how does a self-driving car identify a pedestrian or another vehicle? And how do robots? And how do robots in various locate products and move them to the correct place? All these technologies involve sensing data processing and intelligent decision making. So, laser technology can provide very accurate information about distance, position, and objects. Artificial intelligence can then analyze that information and make intelligent decision. So, in simple way, we can say that laser technology helps us collect precise information, and artificial intelligence helps us understanding and use that information. This is one reason why laser technology continues to be important in modern engineering and computer science. Modern engineering and computer science. So, coming to relevance to computer science, this applied physics is relevance to computer science. So, now let us see why this topic is relevant to computer science. One major application is in optical fiber. You can see here optical fiber communication. One major application is optical fiber communication. So, lasers are primarily light sources in optical fiber networks. What I am saying here, one major application is optical fiber in optical fiber. In optical fiber communication, lasers are used as light source for transmitting information through optical fiber. So another application you can see here, this is data storage and retrieval. Another application is data storage and retrieval, where laser technology has been used in CDs. You can see CDs, DVDs, Blu-ray discs, and optical memory systems and optical memory technologies. Optical memory technologies. So laser-based systems are also important in laser sensors like LIDAR, computer vision, and robotics. For example, radar uses laser light to obtain information about objects and distances. This information can then be processed by computers or artificial intelligence systems. So, although today's topic belongs to this laser, its applications extend into the computer science, electronics, communications, robotics, and many other fields. Many other fields. That's why understanding the basic physics behind laser technology is very useful. Very, very useful. So, coming to here, so learning objective. Learning objective. This is the learning outcome. At the end of the lecture, the students will be able to explain the process of stimulated emission of radiation. The outcome is learning outcome. At the end of the lecture, students will be able to illustrate the process of stimulated emission of radiation using an energy level diagram. This is lower energy state, this is higher energy state. That is lower energy and higher energy state using the energy level diagram. So coming to next one, what is a laser? What is laser? Now let us start with a very basic question. Very basic question, that is what is a laser? What is a laser? You try to see here. So you can see this is the ordinary light. The ordinary light. So what I am saying, this is ordinary light. So this is laser light. You can see this is the laser light. The ordinary light emits the radiation in all the directions, but the laser light emits the radiation only in one direction. The ordinary light emits the radiation in all the directions without any relation and frequency relation. But the laser light, you can observe, the laser light emits the radiation only in one direction with a phase relation and frequency relation. So try to understand here, the word laser stands for light amplification by stimulated emission of radiation. So you try to see here, this is light amplification by stimulated emission of radiation. So before this laser, they called it maser, M-A-S-E-R. So M means microwave, microwave. Remaining same, microwave amplification by stimulated emission of radiation. But these are not a microwaves, it is a light. That's why they called LASER, light amplification by stimulated emission of radiation. So the important word here is stimulated emission. The working principle of laser is stimulated emission of radiation. A laser is different from an ordinary light source. For example, when we switch on a torch, the light is spread in many directions. That is ordinary light. But a laser produces a very narrow and highly directional beam. That is why laser beam can travel a considerable distance with remaining highly concentrated. This special nature of laser light makes it useful in communication, scanning, medical applications, industry, measurement, and scientific research. Scientific. So try to understand here. So this concept of laser light and ordinary light, you try to see. So light from an ordinary source travels in all the directions. You can see it is this spreading is also more. This spreading is also more. Whereas laser light travels in a single direction. Single direction. For example, ordinary light emitted from a torch spreads it widely as it travels, while a laser beam spreads only a few centimeters even over long distances. In contrast, laser light is highly directional, nearly non-divergence, and has a very small angular spread, typically about 1 millimeter per meter. Per meter. So coming to take a small activity. So this is the activity on spontaneous emission and stimulated emission of radiation. Now let us take a small activity to understand the words spontaneous and stimulated emission of radiation. Look at the four situations shown on the slide. So first situation, second one, third, and fourth. If we are hitting with a stone, the monkey is climbing the tree. So the monkey is climbing here the tree. The boy is hitting the monkey. The monkey is climbing the tree. That is first. Second one, the monkey is sitting on the tree branch. Sitting on the branch. So third situation, the monkey is coming from tree to ground state by its own without any forcing, without any hitting. So fourth one is if we are hitting with a stone, the monkey is coming to ground by force. Think about this question. Which situation happens naturally and which situation happens because of an external action or external force? For example, if the monkey moves down from the tree on its own, we can compare that with a spontaneous process. You can observe here, first question, which situation represents a spontaneous process and which situation represents stimulated emission. So I am giving here hint also. A spontaneous process occurs on its own, whereas a stimulated process requires an external trigger or force to occur. So we are telling here what we are saying here, but if an external action forces the monkey to move, we can compare that with a stimulated process. So remember this simple idea. Spontaneous means on its own. So in third, the monkey is coming by its own. That is spontaneous. Stimulated means because of external influence. So the boy is hitting here with a stone, external influence. Here also, the boy is hitting the monkey. The monkey is on the tree. So, stimulated means because of an external influence. We are now going to apply exactly the same idea to that in laser. that atoms and photons, in the atoms and photons. So coming to first one, absorption or stimulated absorption. Absorption or stimulated absorption. So let us begin with the first process, absorption. Suppose an atom, here you can see here, this is the lower energy state E1, this is higher energy state E2, this is the population in E1, this is the population in E2. If E2 minus E1 is equal to h nu photon, energy is incident on the ground state atom. The ground state atom absorbs all the photon energy and goes to higher energy state. This is the higher energy state atom. Higher energy state. This process is called absorption or stimulated absorption. Like a stone is hitting on the monkey, the E2 minus E1 is equal to h nu photon. Energy is incident on the ground state atom. The ground state atom absorbs all the photon energy and goes to higher energy state. Process is called absorption or stimulated absorption. If a photon of energy h nu is incident on the atom, if it gives its energy to the atom and disappears, then we say that the atom absorbed the incident photon. As a result of absorption of this energy, the atom jumps to the excited state E2. Such a transition is called an absorption. So what I am saying here, try to understand here. When a photon of energy E2 minus E1 is equal to h nu is incident on the ground state atom, then it excites to the higher energy state. This phenomena is called stimulated absorption or absorption transition. Let us consider, coming to here, let us consider, let E1 and E2 are the energies in N1 and N2 be the number of atoms per unit volume. So E1 is the lower energy state, E2 is the higher energy state. This is N1. N1 is the number of atoms per unit volume. This is N2. N2 is the number of atoms per unit volume in energy state E2. In energy state E2. So respectively, what I am saying, N1 and N2 be the number of atoms per unit volume in the ground state E1 and excited state E2 respectively. Let rho v be the energy density of photons or the number of photons per unit volume is unit volume, that is rho v. You try to understand here, it is the process of excitation of an atom into an excited state from the ground state by absorbing the incident photon. So what I am saying here, the E2 minus E1 is equal to h nu photon energy is incident on the ground state atom. The ground state atom absorbs all the photon energy and goes to higher energy state. Phenomena is called absorption or stimulated absorption. The stimulated absorption rate, stimulated absorption is directly proportional to number of atoms per unit volume N1 and also directly proportional to rho v, number of photons per unit volume or the energy density of photons. So we can write this is directly proportional to N1 rho v. So proportionality constant B1 to rho v N1. So you can see here stimulated absorption rate B12 rho V N1. Here, B12, the constant B12 is known as Einstein's coefficient of stimulated absorption. Einstein's coefficient of stimulated absorption. So, coming to spontaneous emission of radiation. Spontaneous means by itself without applying any force. Spontaneous emission of radiation, emission of the photon by an atom without any external influence is called spontaneous emission. So try to understand here the excited state atom in absorption, the excited state atom cannot stay long time in the excited state. It can stay up to 10 to the power minus 8 seconds. This 10 to the power minus 8 seconds is called lifetime of the atom. Lifetime of the atom. The atom can stay up to 10 to the power minus 8 seconds. After 10 to the power minus 8 seconds, the atom returns to the ground state by itself. That phenomena is known as spontaneous emission of radiation. Spontaneous emission of radiation. So try to understand here the excited atom in the higher energy level can stay up to 10 to the power minus 8 seconds. After 10 to the power minus 8 seconds, the excited atom tends to return to the ground state or lower energy level by itself. By itself. And emptying a photon of energy, this phenomena is known as spontaneous emission of radiation. So the excited state atom can stay up to 10 to the power minus 8 seconds. After 10 to the power minus 8 seconds, the atom returns to the ground state by itself without applying any external force with emptying a photon. This process is called spontaneous emission of radiation. So try to understand here. So this is the lower energy state E1, this is higher energy state E2. N1 is the population in E1, N2 is the population in E2. Or N1 is the number of atoms per unit volume in energy state E1, N2 is the number of atoms per unit volume in energy state E2. You can see here the excited atom does not stay for a long time in the excited state. The lifetime of excited atom in a higher energy state E2 is typically of the order of 10 to the power minus 8 seconds. So what I am saying, in excited state, the atom cannot stay long time. It can stay up to 10 to the power minus 8 seconds only. That is called lifetime. After 10 to the power minus 8 seconds, the atom returns to the ground state by itself with emptying a photon. This phenomena is called spontaneous emission of radiation. So spontaneous emission rate is directly proportional to N2, the proportionality constant A21 N2. So we can see here this is A21 N2. Here A21 is known as the Einstein's coefficient of spontaneous emission of radiation. So here let us understand spontaneous emission a little more deeply. An excited atom remains in the excited state only for a limited period of time. The typical lifetime mentioned in this slide is around 10 to the power minus 8 seconds. After this time, the atom can return to the lower energy state by emitting a photon. The slide also here introduces the Einstein's coefficient A21. Already I discussed A21, which represents the spontaneous emission process, or that is the Einstein's coefficient of spontaneous emission of radiation. So now, what are the important characteristics? So spontaneous emitted radiation is generally incoherent, that is less directional and less intense compared with laser radiation. So examples include radiation from conventional sources such as sodium and mercury lamps. So what I'm saying here, characteristics, the first characteristics is the emitted radiation is polymonochromatic. So the spontaneous emission is incoherent light. It has less intensity, less directionality. For example, spontaneous emission of radiation example, light from sodium or mercury lamp. So this is the spontaneous emission of radiation. The spontaneous emission does not need an incoming photon to initiate the emission. The excited atom emits on its own. On its own. So coming to stimulated emission of radiation. Stimulated emission of radiation. So here in the excited state, the atom can stay up to 10 to the 4 minus 8 seconds. Before 10 to the 4 minus 8 second, E2 minus E1 is equal to H nu photon energy is incident on the ground state atom. The ground state atom absorbs all the photon energy and goes to higher energy state. Phenomena is called absorption. In the excited state atom, the atom can stay up to 10 to the 4 minus 8 seconds. After 10 to the 4 minus 8 seconds, the atom returns to the ground state by itself with emptying a photon, is known as spontaneous emission of radiation. But here, you observe this point before 10 to the 4 minus 8 seconds. E2 minus E1 is equal to H nu photon energy is incident on the excited state atom. The excited state atom absorbs all the photon energy and stimulates from higher energy state to lower energy state with emptying two photons. One is emptying photon, another one is incident photon. This phenomena is called stimulated emission of radiation. Stimulated emission of radiation. So try to understand here clearly. Let us take a photon of energy E2 minus E1 is equal to H nu. This is the E1 is the lower energy state, E2 is the higher energy state, N1 is the population in E1, N2 is the population in E2. Then E2 minus E1 is equal to H nu photon energy is incident on the excited state atom before 10 to the 4 minus 8 seconds. So what I am saying, let a photon of energy E2 minus E1 is equal to H nu interacts with the excited atom within lifetime. The atom gets de-excitation into ground state by emptying an additional photon. E2 minus E1 is equal to H nu. So what I am saying, try to clearly understand here. Before 10 to the 4 minus 8 seconds, E2 minus E1 is equal to H nu photon. Energy is incident on the excited state atom. The excited state atom stimulates a photon. It gives two photons. One is incident photon, another one is another one is emptying photon. For example, this is emptying photon. This is photon, incident photon. Now we have reached the most important part of today's lecture, stimulated emission. Let us imagine an atom that is already in the excited state. Now another photon comes and interacts with this excited atom. This incoming photon can stimulate the excited atom to return to the lower energy state by the process of stimulating. During this transition, the atom emits another photon. It is called stimulated emission of radiation or induced emission of radiation. This is the process that makes laser light possible. So, if you remember one key point from this entire lecture, remember this laser action is based on stimulated emission of radiation. Stimulated emission of radiation. So, coming to see here, characteristics. Let us look at this process more carefully. The atom is initially in the excited state. An incoming photon is interacts with this atom. So then it stimulates the photon into the ground state. So what I am saying here, now, now you can see here characteristics. It is monochromatic of the emitted radiation. It is monochromatic, meaning it has a very specific frequency or wavelength. So it is coherent means coherent. It is coherent. You can see. Coherent means there is a definite phase relationship between the photon. The two photons are emitting. The two photons radiation has the relationship in phase and frequency also. It is highly intense and high directional. This is high intensity light, high directional, high directional. These are exactly characteristics of laser. So now we can understand why stimulated emission is so important in laser technology. So what is the example? For example, light from laser source. Example, helium neon laser, carbon dioxide laser, and so on. So coming to here, this is the laser action. The laser working principle is stimulated emission of radiation. Stimulated emission of radiation. The photon induced in stimulated process propagates in the same direction as that of stimulating photon. The outstanding features of this process is the multiplication of photons. You try to understand here. So this is 2 to the power 0 means one photon. One photon is incident on the excited state atom. It emits two photons. 2 to the power 1 means it emits two photons. So these two photons incident on the excited state atom, it can give two square photons. One, two, three, four. Two square means four photons it can produce. This 2 to the 2 square photons is incident on the excited state atom. It can give 2 to the power 3 photons. So, like this, in this process, a chain reaction is formed that is 2 to the power n photons. This process is known as laser action, laser action or lasing action. So, what I am saying here, so one photon is incident on the excited state atom. It gives two photons. These two photons incident on the excited state atom, it can give four photons. The four incident on the excited state, it can give 2 to the power 3 photons. In this process, we can get 2 to the power n photons. 2 to the power n photons. In this process, a chain reaction is formed. That chain reaction is called laser action or lasing action. Laser action or lasing action. So coming to the comparison between spontaneous emission versus stimulated emission. So you try to understand here definition, spontaneous and stimulated. So in the excited state atom, The atom can stay up to 10 to the power minus 8 seconds. After 10 to the power minus 8 seconds, the atom returns to the ground state by itself. That phenomena is called spontaneous emission of radiation. So, an excited atom or molecule returns to a lower energy state by emptying a photon on its own. That is the spontaneous emission of radiation. Coming to stimulated emission of radiation definition. Before 10 to the power minus 8 seconds, if E2 minus E1 is equal to h nu photon energy is incident on the excited state atom, the excited state atom absorbs all the photon energy and stimulates the photon to lower energy state. It emits in this process two photons. The two photons are having same direction, same frequency. This process is called stimulated emission of radiation. An excited atom or molecule emits a photon when triggered by an incoming photon of matching energy. So, what is the reason? So, it occurs naturally without any external influence. So, so it is caused by interaction with an incident photon. Photon characteristics. Photon emitted has random direction, phase, and polarization. So it will not give the coherent light and monochromatic light. So photon emitted in stimulated emission of radiation has the same energy, same phase, same direction, and polarization as the stimulating photon. So direction of emission. Spontaneous emission radiation has the random in all the direction. In the stimulated emission, in the same direction as the incident photon. So what about coherence? This is the spontaneous emission of radiation is the incoherent light, no fixed phase relation. But the stimulated emission is the coherent light, so photons are identical and in same phase. What are the examples for spontaneous light emitting diode? General lamp, the sunlight. So stimulated emission, any laser, helium neon laser, semiconductor laser, or carbon dioxide laser, etc. So coming to summary of today's lecture. Let us quickly summarize today's lecture. We started with absorption in this lecture. In absorption, an atom takes energy from an incident photon and moves from a lower energy state to a higher energy state. Then we discussed spontaneous emission of radiation in this lecture. So here, an excited atom naturally returns to a lower energy state and emits a photon. Finally, we discussed the stimulated emission of radiation. In this case, an incoming photon interacts with an excited atom and causes the emission of another photon. Stimulated emission is the fundamental principle behind the laser action. Because of the emitted photons have matching properties, laser light can be highly coherent, directional, intense, and monochromatic. So these three processes, absorption, spontaneous emission, and stimulated emission of radiation from the foundation for understanding the laser. Okay, coming to this exercise problem or questions. Now let us apply. You try to see here scenario question. A supermarket uses a laser barcode scanner to read product information. The laser emits a narrow, coherent beam of light. So you can see which radiation process is responsible for producing the laser beam. Why is stimulated emission preferred over spontaneous emission in barcode scanners? What would happen if the laser beam suddenly disappeared during the operation? So try to understand here. The first question is which process is represents for producing the laser beam? What is that? Try to understand that is the stimulated emission of radiation. Why? Because stimulated emission process produces the highly directional and coherent radiation required for laser operation. Now imagine, now imagine that the laser beam suddenly disappeared. What happens? The scanner can no longer perform its normal laser based scanning operation. This is a simple example, but it shows how the concepts we study in physics are directly connected with the technologies we use every day. Now, let us connect our topic with some technologies that we see around us every day. That is curiosity about laser technology and artificial intelligence. How does your smartphone recognize your face? You can see how does your smartphone recognize your face within a second? Within a second. How does navigation? How does second one? How does navigation, Google Forms, application estimate traffic and suggest a route? Coming to third one, how self-driving cars already very starting I discussed. How does a self-driving car detect pedestrians and other vehicles? Coming to when you order a product online, how do robots in warehouse find the deliver the correct item? So try to understand here. You can see here how do various robots locate and deliver products? And finally, what would happen if AI and laser technology suddenly disappeared? This question helps us understand that physics is not isolated from modern technology. Laser systems, sensors, computers, and AI often work together. Understanding the basic physics with laser concepts and artificial intelligence concept behind these systems can therefore help us appreciate how modern technology actually work. Let us example. You can see here. Let us discuss these examples briefly. You can see here. These are the answers you can see. In face recognition, sensing technologies can help collect information about facial features, while artificial intelligence algorithms analyze that information. So coming to second one answer, you can see these answers here. In navigation systems, large amounts of data are processed to estimate traffic and identify suitable routes. Coming to self-driving cars. So try to understand self-driving cars. The answer also you can see in self-driving cars or vehicles, LiDAR can use laser pulses to scan the surroundings and detect objects with high precision. Artificial intelligence can then process this information and help identify and track those objectives. So coming to fourth one, in warehouses related automation, robots can use sensing technologies to locate product and avoid obstacles, while AI helps with decision making and Path planning. Now imagine a world without laser technology and artificial intelligence. So many technologies that we take for granted would be affected. from advanced sensing and optical communication to automation vehicles, whereas automation and some medical and industrial applications. So we cannot take the face unlock and so on. So today's lesson is not simply about atoms and photons. It is also about understanding the physics that supports modern technology by using laser technology and artificial intelligence. Artificial intelligence. So try to understand here. Can you identify three technologies you used today that really on both artificial intelligence and laser technology without you noticing? So you can also see this is the number one smartphone face unlock, second one Google mapping, third one YouTube, Netflix recommendations. So here you try to understand here artificial intelligence is the brain that thinks. Laser technology is the eye that sees. Together they make our world smarter, faster and safer. So AI plus laser technology, you can see here, intelligent tomorrow, better today, better today. So coming to today's end of the lecture. So we have come to the end of today's lecture. Let me leave you with their three simple ideas. Absorption, the atom gains energy. Spontaneous emission, the excited atom emits a photon naturally. Stimulated emission, an incoming photon causes an excited atom to emit another photon. And most importantly, stimulated emission is the fundamental principle behind laser action. I hope this lecture has helped you understand these concepts in a simple and clear way. Thank you very much for watching this video. Keep learning, keep asking questions, and keep exploring the fascinating world of physics, laser technology, and artificial intelligence. Thank you, and see you in the next lecture. Thank you so much.